Alright guys, welcome back. We're going to look at particle diagrams, specifically elements, compounds, mixtures, and then we are going to classify homogeneous and heterogeneous mixtures from a picture. Okay, so elements have one type of atom. They can be single or diatomic. Diatomic means two together, but they're exactly the same. So hydrogen comes together, so it'd be two dots, and I'll show you one of those in a minute. Okay, I want you to copy these definitions down, and I want you to draw up the pictures next to them. You might want to use a colored pencil or some crayons or two different colors. Okay. Compounds have two or more types of atoms, and they're bonded together. Okay, bonded, and here they are one type. Okay. Mixtures, they're a combination of elements and compounds. So you might have a few elements and a few compounds, or you might have just two elements together, but they're not touching. Okay. Then you have homogeneous. They're uniform throughout, and heterogeneous are just not dispersed evenly. Okay. So let's see what those look like. We'll copy this down a little. Well, I want you to put this in your journal. Brinkelhoff. Okay. Exactly the way it's written. Br2, I2, N2, Cl2, H2, O2, and F2. And it's called Brinkelhoff. Those are our diatomic elements, and we'll talk about those later on as we go on into the periodic table. Okay. I want you to draw this one. It says identify the following diagrams. So, for instance, this one here, this is an element. And I'm going to put an E here for element. This is an element. These are diatomic molecules here, okay? So go ahead and copy this down. Make sure you use colored pencils. This one is also an element. I'm going to put an E here for element. It doesn't have as many, it's just one. Okay. This one is a compound, so I'm going to go ahead and put a compound. You see that there are two different colored dots here, and one's large and two are small. That means that they're together. They're bonded together because they're touching. This is a mixture. This is a mixture. And I'm going to say, if I were to be venturing, I would say this is homogeneous because there's a certain amount. But then again, it might be heterogeneous because we're not really sure. It's hard to tell on these kind of diagrams. Alright, this one is also a mixture. You notice that even though there's two sets of elements, they're not touching, they're just out there. This one is a compound. They're touching right here. There is a bond right there. Okay. This is a mixture. This is also a mixture. Here's an element, here's a compound. But these two things right here are not touching, so that makes them a mixture. Alright. Let's see what I want to do. Okay, so mixtures, elements, compounds. Number of type of compounds and elements, heterogeneous or homogeneous. Okay, so mixture separation, there's no chemical change. We take salt water, we just divide it into salt and water. But you notice this is the mixture. Okay. But if we take water and we turn it into hydrogen and oxygen, that is a chemical change. We've taken a compound that looks like Mickey Mouse and we've turned it into two diatomic molecules. So here, let's identify the following changes. So if we take this compound and we turn it into elements, this is a chemical change. Okay, chemical change. Okay, chemical change. This one is a physical change. Physical change, because we've just taken the mixture and we've separated them. And this last one. What do we think we're doing here? Okay. This is a physical change. We've just separated them. Same thing here. Physical change. You know what? Let me go back. This one is not a physical change. It's a chemical change. I just thought about that. Because they are bonded together, and then we took them out of bonds. Okay, this one, though, is a physical change. No bonds, no bonds. And that's it, guys. I'll post this video and get you guys another video.